Perfect. Hello, everyone. Thanks for being here and thanks for waiting. So my name is Filip. I am currently in the last phase of my PhD at TUM, so I see a couple of familiar faces here, but I'm also happy to present a project I'm co-founding called SpaceComputer, where literally it's out of this world programmable cryptography that we will be talking about. And yeah, without further ado, let's dive into it. Maybe not. Perfect. So, out of curiosity, from people in the audience, who has heard about SpaceComputer? We are rather a young project, but I see a few hands up. That's great. We are doing our job properly. So, for some context, we have released our blue paper roughly last year in November. So it has been quite some time that we are already, putting out the idea, and now we are keep actively building on all of the individual technical details. Just in a nutshell, what we are trying to achieve, SpaceComputer is a distributed network that is running among satellites in space, where the idea is to provide a robust and secure settlement layer, where each of the individual satellites also serves as a trusted execution environment. And this is the reason why we are also a general purpose confidential compute platform. Some of you might be asking, why space, right? So also for other aspects that we maybe already are familiar with space, it's expensive. Still it is the case, but from what we currently see, due to companies like SpaceX and many others, the cost for launching your own stuff into space is becoming decreasingly lower. So if you look at it, we see, firstly, increase in the amount of payloads that are being sent. So in the last 2 years has been sent more assets into space than in the past decade. And the other part is also very important for us, especially for those who are into space. Starship and other activities that are making and enabling the aspect of sending your payloads into space very, very affordably. So for that, we see a definitely massive decrease in the cost per kilogram, which makes our project very attractive for the part of building up an infrastructure that actually can already be up in space, and we see an interesting value proposition in that sense. We used to think that especially space activities are mainly focusing on imaging. Actually, this is still the case when you look at the number of satellites in space are mainly used for imaging and are partially, but start to be more privatized. We also know that we are using some of the space activities on a regular basis, either through GPS and others as a part of location services, weather forecasts, and communication infrastructure such as Starlink. But we start to see that more and more space as a commodity is becoming more and more available, not only to public sector, but also to private sector, which is very interesting for us, where we want to position ourselves. So some of you may be asking, why blockchain in space? What is the additional value that we want to provide? So the main aspect, of course, is that we see that there will be many additional use cases that can be unlocked to the aspect of on-Earth environments. But the other part is that due to the fact of the dedicated physical isolation that you are getting, you can actually strengthen the trust assumptions in your overall deployments that you have. So you can think of it, there are no borders. It's beyond reach, right? Like it's quite hard to get a hands on your particular device. It's immune to physical tampering. And in general, it's providing an ultimate tamper-proof and censorship-resistant layer that we want to build and leverage for our protocol itself. So overall, what we want to provide is a robust layer 1 that it will be running among the satellites in space, for which we have to deal with the communication aspects that can be either dealt by us or by the infrastructure partners we'll be providing. Each of the satellites should have capabilities of trusted execution environments. And of course, to enable the next generation of capabilities, we want to be a smart contract platform which enable people to run their arbitrary program on each of the individual satellites themselves. And overall, since more and more activities are happening in space, we start to see aspects like cloud-based compute and so on that will be actually happening on the platforms in space. We want to provide a marketplace and payment layer that can build and be aspect for the next satellite services that will be running natively in space as well. For that, we separate our ongoing activities into 4 prongs. So first one, it will be the celestial blockchain itself, which will be the layer 1 and serve as a root of trust. So we are combining the aspects of the overall satellite into the distributed network, but of course each of the satellites should also serve and provide its own capabilities. The second part will be the uncelestial blockchain, sorry for the typo, which is the layer 2 on Earth, because we need to have a scalability to provide other type of features. The third one is the security services, which will be the capabilities that we'll be providing to users on Earth as well, which will be something like a spaceTEE, which I'll be talking about a bit later, cosmic random number generator, and many others. And the last prong is focusing on increasing and providing capabilities to the users, which will be to the trust minimize gateway, which we call orbit port, where the users can use this to interact with a space-based infrastructure, either of our own, but hopefully for the future also with some other type of users as well. I already briefly touched on that we are relying on two-tier, but why two-tier architecture? So combining the aspect of space with activities on Earth, many of you might know that space is still not as where we are with respect to compute and communication resources as we have on Earth, for which we naturally led to design our system in such a way, because we know that the L1 itself will be limited in TPS, and we will definitely have quite a high latency, definitely high finality as well. And for that, we are looking into suitable solutions for the scalability. We also want to ensure that among the individual peers, we provide a robust communication as well, which will mean that we need robust inter-satellite communication. And of course, what we also have to also ensure as a part of our design is that we provide dynamic upgrades for the consensus during the runtime, because we are optimists, and what we definitely see that the aspect of space is evolving, and where we currently are doesn't necessarily mean that the space industry itself will not proceed in the next 5 to 10 years with aspects of dedicated communication, improved bandwidth, lower latency, and so on and so forth, for which we have to be able to adopt our system as well. So starting with one of the aspects of the value proposition, it's a computational resilience. So this is something that is we call spaceTEEs, because they will be running in space, of course. And TEs are cool, right? As we have heard in several previous talks. And just a brief context, what are TEs for those that are not familiar? So it's a dedicated, isolated region on your CPU that is providing additional instructions to the applications. And it's supposed to provide secure location where you can run your code and data, and provides confidentiality and integrity to the users that are interacting with the system. However, especially if you look at current TE technologies on Earth, like for example Intel TDX, Intel SGX, and others, especially on the confidentiality aspect, they sometimes are a little bit lacking due to the fact that they can be exploited by the malicious host, hypervisor, and there are quite a few side channel attacks, which is basically the reason why we want to provide and run our infrastructure in space, due to the fact that many of these types of attacks are no longer possible, strengthening the threat model of the overall system as well. And what, of course, is very crucial for the aspects of TEs is to provide remote attestation capabilities, because you want to make sure that other people that are interacting with your infrastructure can get a confidence that are actually interacting with the environment where the code and possibly data are ran in a sensitive fashion as well. So I already mentioned some of the aspects that already are known technologies as of now, either process-based or VM-based solutions. But of course, we've tried to combine the software approach together with the physical isolation, where in addition to that, we are also looking into dedicated aspects provided by the hardware. So especially in that sense of the space infrastructure, we are looking into the context of running combined ARM CCA or ARM Trust Zone together with the physical isolation properties together, providing a unique bundle itself as well. Focusing on the aspect where we definitely see many relevant use cases, just like I picked one of them, is the part of relevant for the Ethereum ecosystem, which are the challenges in the layer 2 as they are. That some of them we definitely help to solve. So one of them is, for example, focusing on the aspects of providing dedicated multi-probable model for the using our trusted execution environment technology for already existing ZK rollups, where we know that as of now, in case there is a bug in the soundness of the ZK rollup or others, it can lead to many issues. And for that, we start to already see in the context of space-based, in the Earth-based infrastructure, multi-prober solution, which was also recently proposed in a nice blog post by Vitalik. And already there are companies doing it in the wild as of now. But of course, in case you would combine it with other additional guarantees provided by spaceTEE, it could be much more beneficial for the users as well. Another part that we see, especially in the optimistic setting, is that we have a lot of trust in the sequencers. And of course, this means that they can provide censorship. But even after, for example, they make sure that there is the opportunity when you settle your stuff on the L1, you are still waiting in the case of optimistic rollups for a window of opportunity for 7 days, which is the part where you have to wait for the part to make sure that your conflicts can be resolved. And in case at that point an attacker actually chooses to stage an attack on basically the denial of service, the cost of staging such type of attacks on the optimistic rollups is not so significant. There was a nice paper about it recently from the team of Arbitrum that actually quantified on how much such type of cost would be, and it's surprisingly low considering the value that actually can be extracted by that. So for that, having a dedicated communication path could be actually very interesting as well. So overall, we of course see many interesting aspects in addition to that, but as of now, you can think of us as a part of the defense in depth, but there are many more use cases that we will be talking about in the upcoming days, so stay tuned. We are actively releasing all additional parts, but this is just like for the initial idea that you can think about. Diving a bit deeper on how the user actually will interact with our system, so we will have the users on Earth. They will be interacting through our gateway, which as of now, you can think of it, it's trusted due to the fact that it's being operated by us, but we are still a little bit far from the mainnet, so it's not a problem, and we are aware of that and try to solve this type of issues by making sure that the party that basically is operating it can be anyone. So we are looking into the ways on how to make this infrastructure permissionless, so other people can run it, and also provide additional security guarantees as well. And of course, combining the part of the layer 1, the single node approach, and the gateway, we will eventually see the part where the individual information coming from the users on Earth will be stored later on the settlement layer in space as well. As of now, we aim to be EVM compatible, which means that any type of current layer 2 solution can easily be ported or deployed on our L1, and users can also later on interact with the same functionalities as they are from other chains as well. I already briefly touched on that, but this is like one of the early features that we are offering as of now with our satellites we already have available. So we already provide and have access to one satellite, which is providing us the cosmic random number generator, which allows us to get quite a unique capabilities with respect to randomness. We already have several demos for that and are currently looking into integration with several Oracle providers, so that way, in case you are building your D app, you can actually later on get the randomness into your application, which is very relevant for many type of solutions. And as of now, what we are trying to achieve is that people have an access to their randomness, same way as they are used to from other type of solutions. So in case you want to get a D app, you can basically use it, but we are also looking into the way not only providing integrity of the randomness, but also of course confidentiality until it reaches the user's own chain as well. So for that, we are looking into integration of this randomness into also cryptographic protocols, but also into consensus protocols and others, which can make it quite attractive as well. Orbitport is one of the initial part that basically will be serving and onboarding additional businesses as well. So we have a dedicated roadmap for that. For example, we of course want to provide custodial services with respect to storing your partial keys among the satellites themselves, which of course it's a very robust root of trust if you consider that you can have multisig and you want to store some of the partial keys among the satellites. But it can go beyond that. We basically want to have a whole SDK that if you want to deploy your TEE application, you should be able to do so without much of any problem. You want to run your applications that are actually relying on multisigs, it should be basically unlocked by the features and the scalability of the system, because we already are commissioning several new satellites next year, and we plan to scale until we have a full-fledged constellation of satellites themselves. So, you know, as of now, I was touching on some of the few ones, but you can definitely think of it as a long-term future where we'll be unlocking many new capabilities to users on Earth as well. For that, we released recently a roadmap, which is currently, we are in the ignition phase, so we are still rather early, where the next and the final aspect of the ignition phase will be to finish with our white paper, which will be specifying the details of the layer 1 protocol itself. And later on, we aim to also provide additional capabilities. So in case you're interested, there is a link to the demo. Feel free to reach out to me. I'll be around as well for a couple more hours before I head home. And yeah, if you are interested in building with us, get hands-on some randomness from space and beyond, let me know. Thank you very much.